Welcome to RSAC Conference 2025. We're recording from the CyberRisk TV studio at Marriott Marquis in San Francisco. Thank you to the sponsor of today's media partner program, CyberSG TIG Collaboration Center. I'm your host, Adrian Sanabria, and joining me for this interview is Go Encryption, President Cyber at ST Engineering. Welcome.
Thank you. Good to be here.
Yeah, good to talk with you. So I am new to ST Engineering. Just before we started recording, learning a little bit about it. So maybe start with the cybersecurity focus of ST Engineering. What kind of products, services you have?
Yeah, I'll start with ST Engineering. So we are a global defense and technology powerhouse. We have businesses all over the world, even in US as well as in other part of Asia and Europe. So within the business, there are a couple of key business areas. One of them is cybersecurity, which I run, and we have been building up the cybersecurity capability almost 25 years ago, and today is quite formidable because we have product and then we have system and as well as services.
All right, yeah, and I imagine a lot of those services. A lot of your clients are very interested in everything that's happening with AI, quantum, things like that. So that's a lot of what we're going to talk about today.
Sure.
And just starting with how AI has enabled threats. I think it would be good to cover a little bit of that first, because I think any sufficiently useful technology can be used by both sides, right?
Yeah, that's right.
Good and bad. Dual use, I think, is the term.
Yes.
Yeah.
So let's talk about AI. It's something very interesting. If you walk the floor of the exhibition, you probably see a lot of AI being implemented. But on the reverse side, we also know that the adversary use AI to their favor to actually attack any organization at a very efficient and fast way. So similarly, on the defender side, we also need to have AI to fight AI. So we need to use AI to actually enhance the capability of the defender to actually go against the adversary they are using AI to actually generating all the different type of malware and very fast speed, formulating phishing email that's practically flawless. So it's important for the defender to do so at the same time. But you also know that AI is being implemented in many organizations today. As they are doing the implementation fast and furious, there's also a need to kind of flip the other way that you have to use cybersecurity to protect AI. How do you prevent AI from being poisoned, to create hallucination and all this? So this is something that ST Engineering has been doing for the past few years. We have invested quite a bit on first using AI to enhance cybersecurity. So our cybersecurity operations center, for example, we actually use AI to be like a co-analyst, working side by side with the actually human analyst.
Yeah.
So that helps the human to actually enhance their capability, much like a superpower to them. Then we have another team that actually looking at all the organization implementing AI for their processes, the operation. So what we actually did is that we building the capability to detect and protect the AI from being manipulated, and also the AI for the database and all this from being poisoned. So these are things that we are doing. And today, in RSA in 2025, we are showcasing some of this capability.
Yeah, you have a booth on the show floor.
That's right. Yeah.
On the expo. Yeah. And it's interesting. We're starting to see AI models that are more specialized as well. I think I've seen some announcements about cybersecurity specific models. I don't think they're training them from the ground up for cybersecurity, but maybe taking Llama 3, like some of these existing foundation models, and fine-tuning
that's right.
for cybersecurity.
That's right. Yeah, there are many angles to deal with it. But I think it's important is that the human factor mustn't be forgotten.
Yeah.
So constantly, we always thought that AI will replace human, but I think in this case, it is important that human with AI probably will do better than human without.
Right.
What's important is that the human has to be there for the ethical reason, building all the guardrail to actually protect. For example, to protect the boundaries of how much the AI can do.
Yeah, and it's certainly as quickly as the technology changes, we need some quality assurance in there, right?
Yes. Yeah.
Now, every time you change models or you change alignment, system prompting, like all these things, as a non-deterministic technology, can change the output.
That's right.
Sometimes
Yes.
the output can be unexpected. So depending on the use case for the AI, maybe you can fully automate it, not have a human in the loop. But for other use cases, maybe somebody needs to check the output.
Yeah. So most of the time when we implement AI, it's not so much about trying to automate it. It's just going to cover the gaps, either enhance it with the speed, but more importantly, at every step of the way, there's always an opportunity for the human to intervene and to be as part of processes so that you can make sure that the guardrail are all protected.
Yeah, and it's yeah, and it's just talking about attackers. The more they automate things, the importance of speed. You mentioned before. A manual human, can't outrun an automated attacker, right?
That's right. Yeah.
So it's and we've seen with a lot of the new threat reports coming out. I like that a lot of them are focusing on, okay, how fast do I need to be to patch this quickly enough, to contain this threat quickly enough? Like what is that time? How quick do we need to be on the defender side to stop some of these attacks?
Yes. So for the defender, they have another problem. Of course, if you have an AI capability, you mustn't be just looking at reacting to a threat. So if you know that the attacker is using AI, nothing stops the defender to have a separate red team to use AI to generate the attack, so that you can actually prepare yourself even ahead of time. So you kind of like shift from a reaction or reactive posture to a predictive and preemptive posture. So I think that's important.
Yeah, it's very important. It's I think for a long time we would set up defenses just vaguely, just generally,
that's right.
like we think these are best practices. We think these are good detection rules, right? But without any kind of real world testing, without emulating that attacker, how do you know? Until the actual attack comes, which is, not a good time to get prepared.
All I can say is an exciting time for both. Well, I guess for the attacker, but because they have no boundaries, they have no legislation to control them. But it's even more exciting time for the defender, people like us.
Yeah. So let's shift to talking about quantum somewhat. Very, very interesting, seeing a lot of advancements in quantum computing, but a lot of questions as well. When it's going to get to a point to where maybe it's a threat, or how useful it's going to be, what kind of problems we can use it for. And, again, talking about AI being non-deterministic, quantum has some interesting quirks as well. So maybe tell us a little bit about, it seems like I've seen two use cases for it, for cybersecurity, or two things that we should be aware of. One is random number generation, so entropy, and then the other is, the concern about the threat of decryption, of quantum being able to decrypt some asymmetric algorithm. So, tell me a little bit about what you're doing there.
Okay, so again, similar like AI, we have to start preparing way ahead before something happens. So if you look at where are the threats, I guess everybody is anticipating the arrival of quantum computing. So for example, Google in some articles has talked about breaking very sophisticated computation at about 200 seconds. That normally you take a supercomputer about 10,000 years.
Right.
So we are not talking, we are talking about seconds vis-a-vis millennia. And I think the important thing is, in the arrival of quantum computing, the biggest fear is that the ability to break every traditional encryption that we have today in much shorter time. So which is why you also notice that there's a rush into quantum ready or quantum based security. So whether it's talking about post-quantum cryptography or you're talking about quantum key distribution. So these are things that ST Engineering is going ahead to try to implement. And there are different forms and different size to it. And it's important that we try out everything. And then it is not a single solution that will solve every problem. So you have to couple with capability to manage them at the same time before the arrival of quantum computing. So these are the challenges that we are already embarking on.
And it's a big challenge. Encryption is used in so many different places. So I imagine maybe you have assessments, crypto assessments, finding all the places it's used, keeping track, maybe having a catalog
Yeah.
of everything. And yeah, big challenge to update. We don't know how much time we have,
We don't know. Yeah.
so we have to start now, right?
Better start now. Yeah.
Yeah.
Of course, the literature says that the quantum computing will come maybe by 2035.
Mhm.
But in my opinion, I think it should be much earlier, or it can be even be faster. And what's interesting that we also notice that people are using AI to actually help them to move or develop the quantum computing a bit faster
Oh,
by
okay.
using AI to do error correction,
Oh, really?
analysis.
Okay.
So you actually
Yeah, 'cause
see
error correction's a big problem with
combination
quantum,
of AI and quantum. That's exactly that. Yeah.
Yeah.
So that's something the world has to brace itself for that kind of changes that's coming fast and furious.
And it's my view of these things is very U.S. centric. So I know that we have our standard, like the finalized algorithms.
Yeah.
I don't know how much the rest of the world is maybe coming up with their own standards, their own algorithms, or if they're using ours. So I don't know if you want to comment on that, or also the regulations. So we might not know when quantum computing gets to this point, but I think I remember seeing Australia has already set a date, right? Like some countries have already set a date, that at least government needs to be done by this time.
Most of the country, first back to the point on US, I think US is definitely taking a lead in this, and the rest of the world are following and observing, at the same time trying to get plugged into the development of the US in this area, especially in the form of standard, like NIST standard and all this, for PQC, and then hopefully even QKD and so on and so forth. On the other hand, they are also preparing the quantum computing attack. So most of the country are setting a certain timeline that all their sensitive information should be quantum safe, before the arrival of the quantum computing. Yeah. The only issue is when will that standard be stabilized?
Yeah.
When will the standard be commonized? I think this is something that everybody is still exploring.
Okay. Yeah. Yeah. And finally, before we wrap up here, this is something I've been talking about already at RSA a lot, is collaboration, is sharing information. So it's not just on quantum, but I feel like on all things in the industry, there's a lot of sharing of threat information, but it seems like we need to do better sharing on the defensive side as well.
Yeah.
Yeah.
So I guess it will be a combination of where the government and the authorities, they drive the needs, and of course we also know, like defense and all this, where most of the sensitive information are, but the industry can play a role.
Yeah.
Because the industry can be plugged into many of the innovation and technology, so they can work together with the government on that. But I think because we are talking about the future, so it's something that you cannot ignore the research institution coming from our university, our labs, the national labs. So these are how the interplay between all of them. I think it's important for the government, for the industry, as well as for the research R&D institution, university, to come together as a one team to actually develop future capability to tackle a very complex solution caused by AI, quantum. But come to think of it, it can also be a combination of AI and quantum.
Yeah. And it's one of the things I like about cryptography is it's one of the things that is backed up by math. It's a very there are very few certain things in cybersecurity. To some extent, we have to guess about what defenses work and don't, and it's updating our cryptography standards makes sense to do for everyone, right?
That's right.
It's everybody needs to protect the same secrets and have that same level of protection. So, Eng Chun, thank you so much for talking with me today.
Thank you very
great
much.
conversation.
I enjoy it.
Love covering these topics. And to find out more about ST Engineering, you can visit securityweekly.com/STRAC. For all RSAC 2025 coverage by Cyber Risk Alliance, including the other 6 interviews from our media partner program with Cyber SG TIG Collaboration Center, please visit securityweekly.com/RSAC. Thanks again.
Thank you. Yeah, thank you very much.